I want to thank everybody for joining us today. Today's presentation, presented by Astrix Technology, is entitled Toolkit for Building a Successful Digital Transformation Strategy. Today's session is, again, presented by Astrix, and we can go to the next slide, please, and we'll get this kicked off. So real quick, before we get into the presentation materials, I want to take a moment or two just to tell you a little bit about who Astrix is. If you have not engaged with us in the past or been part of any of our webinars, we are first and foremost an informatics professional services and strategic outsource solutions company. We are dedicated to servicing the scientific community solely. A couple of quick stats about the company. We were established in 1995, it's currently privately held. We originated as the IT division of a company called APBI, Life Science Research Organization. We operate from 7 offices in the United States and beautiful Costa Rica, and we are headquartered in Red Bank, New Jersey. The target customer for us is a Fortune 1000 life science enterprise, chemical, CPG, government research institutions that have large and fast-growing IT, outsourced, or compliance needs. The mission of the company has and always will be to deliver scalable, sustainable solutions for the scientific community. Go next slide, please. So the group we're talking to today is our professional services group. The professional services group provides end-to-end services which span the complete life cycle of your scientific data systems. That's what we focus on predominantly. And what by life cycle, I mean it begins with us with helping you understand your business process analysis needs. We try to go through and ensure that your informatics projects are built in such a way that they're going to meet the business needs of the organization. Okay, that's that whole notion of the business process analysis. Then we do an enterprise architecture where we basically are speccing out and designing what the technology stack should look like based on, again, what comes out of the business process analysis. And then there can be laboratory technology selection services where we help you select the right technologies to put in your system, to put in your environment. There's the development and implementation of these systems, and then when you're finished, the computer systems validation of them. There's 360-degree laboratory system services, which we can basically be a support agent or an ongoing resource for you after the fact. And then we can even staff both technical and scientific professionals in your lab. At the end of the day, we evaluate, implement, and manage systems to enhance the collection and processing of scientific data. So with that little bit about Astrix, I now want to just introduce our speaker. His name is Dave Dorsett, and he is coming today with more than 30 years of experience in R&D informatics throughout the global pharmaceutical, chemical, and consumer goods industries. He brings an extensive track record of everything from architecting and designing and delivering commercial and in-house informatics solutions across a broad range of R&D areas, from early research through late-stage development and manufacturing. So Dave, I'm going to go ahead and turn it over to you, and I will come back on at the end.
Okay, thank you very much. Good afternoon, everyone. Thank you for joining us here today, this afternoon on what's obviously a slow news day. Absolutely nothing going on. So I'm glad to see the attendees, and hopefully this will be a useful discussion today. What I want to basically sort of lay out firstly here is what I'm hoping to convey today through this webinar. My goal is to really try to give you at least a couple, 1 to 2, different aspects of what a digital transformation program might entail, some things that hopefully you can consider more deeply or that are beyond sort of the obvious, let's just say. I'll present and discuss, a variety of different approaches used in these types of programs. I have been engaged in a number of these over the years, and they're all a little different, as we'll see and kind of get into a little bit. But I want to try to give you at least some flavor of the types of approaches actually used in these types of quote unquote digital transformation programs. This is a very large subject area. It is a lot of it in terms of the way these programs run, and aspects about them are very specific to the organization that's actually undertaking them. But I want to try to give you some things to think about here in this, and some aspects of things that have worked, and maybe a few things that haven't worked as well. And then hopefully, we'll get some questions as well. We can talk a little bit more at the end with anything that's more specific in your mind about your situation or your particular interest. So let's start with a little bit of background. This is digital transformation is current form. of a buzzword that's been going around for a while. It is a very popular topic these days. There's a number of companies throughout the spectrum of folks that I work with. Again, that's life sciences, R&D, as well as chemical consumer products that are engaged in these types of initiatives or have intent basically to undergo some form of a digital transformation. It's actually been happening for a long time. I mean, the buzz phrase has pretty much been dominant or widely used, let's say, in the last several years, but actually this goes back for quite a ways. 10 years plus or minus ago, we had a number of initiatives in this industry that were going by phrases like paperless plant, for example, and those are very similar in most substantial ways with the types of things that go on in these today's digital transformation programs. And again, we'll talk a little bit more about this. Today, over the last several years or so, obviously our labs are becoming more and more digital. So we are continuing this journey basically from an instrumentation and analytical standpoint, and just an overall, sort of operational point of view from the labs that, more and more truly digital things, much more interconnectivity between things. And so as a result of that, increasingly there's a fair amount of pain in the laboratories from an operational standpoint, dealing with sort of the disconnect between digital and non-digital processes. And as we all know, this affects our data consistency, data integrity, our ability to reuse data, even compliance, et cetera. And so that's been sort of one of the laboratory changes in the digitization of our instrumentation and our equipment have actually been also driving a large amount of interest in this over the last, particularly in the last several years. The advent of remote sensor technologies and the Internet of Things aspects, and more and more of what we have and what we do in a laboratory environment is digitally instrumented these days. And to go with this, of course, the classic gap between digital information, where we are directly digitally capturing data in its native form or in a native form, versus electronic data, which I'll characterize loosely as being data that's typically converted from other representations, like, for example, scanning the classic paper printout from an instrument. That gap between those is one example of the issues around efficiencies and consistencies and questions of use, and do I have the actual correct, complete information? And underlying a lot of that, of course, is also issues with, as we obviously produce more and more data in native digital formats, fundamentally, if you can't find it, it might as well not exist. And so these types of things going on in our overall ecosystem are what's one of the driving forces for these types of programs. And we'll talk a little bit more, we'll expand on some of these things a little bit. So if I'm going to characterize what makes up a digital transformation program, as opposed to other types of projects, I think that, in general, as a general statement, most of these programs are thought of as basically having two goals, two axes of improvement that they're attempting to address. They typically have large scale, sort of large organizational levels goals of improving operational efficiency. So we want to, the classic, we want to be able to improve our productivity with our existing resources types of things. So, there's a view to, how that might be done as part of a digital transformation program that we'll expand upon through this. Another axis that these programs really try to focus on is the value of data. So there are a lot of these programs that are driven by, sort of concepts of being able to reuse data, being able to better or more intelligently take advantage of the work that has been done previously, et cetera. And these are not new, new goals for any type of R&D informatics program. With respect to digital transformation, one of the relatively unique characteristics of these types of programs is that we're trying to simultaneously be able to basically work against both of these types of goals. So ideally wherever you are in sort of the lower right quadrant of some graph around your use of data and your operational efficiency, you know, the goal of any kind of these programs is to move you up and to the right, improving operational efficiencies at the same time we're improving use of data. That's sort of the simplified version of this. Of course, the reality of these programs, though, is that, you know, the real world path is not that simple. It's very, very difficult to smoothly, let's just say, move from the lower left to the upper right. And the real world is full of much deeper challenges in the practical aspects of doing these types of things, where the trade-offs essentially between a focus on operational efficiency versus a focus on use of data kind of come into play. So, you know, most real world progress on these kinds of things is a much more squirrely sort of line in things. A little bit more about the journey that I see a lot of folks, a lot of companies going on in these types of efforts. So, you know, sort of the idealistic, moving from our current mode of operating, we'll label it here traditional R&D, you know, into some future state of digitized digital science / digital transformation types of things. There's a lot of different characteristics of that journey. There are 6 listed here. These aren't the only way to sort of characterize aspects of your operations and your organizations in this terms of path between your current state and that future state of digitized R&D. But, you know, each of these types of characterizations here on this particular slide can have a particular path to it. The priorities for any given organization, you know, that are of these things, of these 6 examples here that are listed, might certainly be different. Certain organizations have certain internal goals where, you know, improving the analytics, for example, is a very popular one that typically is high on the priority list compared to others. So these are the types of things that actually make these kinds of programs actually fairly complex. Sort of these interwoven organizational goals that at some level are both, you know, highly qualitative and a little bit sometimes vague or squishy versus the operational types of things which tend to have hard targets associated with them. So that's a little bit about just sort of the background of the types of programs and their you know, their driving forces and some of the priorities that different organizations actually put to them. I want to talk now a little bit more about sort of how programs like digital transformation programs tend to be set up and some of their aspects. First of all, it's pretty obvious as a sort of conclusion from the last couple of slides or so, but fundamentally, whatever roadmap you would have as an organization or part of this program, it's not likely to be the same as any other organization. Your opportunities for change, your current state, your prioritization of the future state, all of those things make every organization different from every other, as well as, very importantly, the culture of the organization itself. So, you know, from a general perspective, doing a webinar like this and you know, sort of a general for the general audience, you know, it's very challenging to sort of say, okay, here's a magic roadmap that fits all sizes. It's just not realistic in any way. Another aspect of these types of roadmaps and these types of programs is sort of the classic people, process, technology, you know, 3-legged stool types of things. Being fully digital, achieving that end state of any type of program like this will deeply impact all 3 legs of your organization in this way. It's not just a technology project or program. It's not just a people or process program. And part of the journey, if you will, of moving from whatever your current state is to some future more digitized state is making sure that that stool doesn't fall out of balance. We want to be able to keep the legs of the stool sort of balanced throughout the whole of this process. So in terms of setting up your program, you know, one of the common themes that I see in these types of working with folks on these types of things is that this is very often viewed as a quote unquote IT project. It doesn't mean it's not funded by or initiated by, you know, sort of the scientific organization or anything else, but you know, a lot of the view towards these things, and both internally within companies, frankly, as well as externally in you know, sort of consulting organizations and such, is that this is an IT project, and the classic sort of IT comfort level thinking, et cetera, would be to, you know, we're going to focus, you know, to order this, basically the focus of this basically in roughly technology, process, and then people. I will say, you know, first off, flat out on this type of program, this is completely backwards. This program, digital transformation, is fundamentally at its core not a technology problem, not a technology project. It is not like I'm going to go out and buy something and implement it. You know, I'm going to, you know, buy something, configure it, implement it, etc. The scale of the struggle, the challenges in these types of programs are very, very different than sort of classic IT projects, and I'll expand upon that a little bit more in the next several slides or so. So, what I want to try to encourage folks when I initially talk to them about these types of things is don't think about this as a technology project, frankly, at all. First and foremost, think about it as a people project. That is the most important aspect of any type of digital transformation program as far as sustainability goes. For these types of things to achieve these goals of efficiency and more productive use of data, more insight into what your organization is delivering, in order to have that kind of a sustainable effect on your organization, that's really where the people first part of it actually, you know, kind of must come in. So a big challenge and a big part of any one of these programs, from, you know, my point of view in terms of like recommendations that I make about how to set these kinds of things up and how to get started on these types of programs, is finding the right leaders for these programs in your organizations with the right kind of, I put it in quotes here, a data mindset. So, you know, this is all, I guess, sort of semi-obviously, digital transformation is all about data, but it's about, you know, a certain mindset towards data as being, you know, sort of something that is, you know, collaborative within the organization, not an individual type of thing. It is something that should drive decision making, decision thinking. Finding people in the organization with the type of mindset that you really need to push these types of transformations, you know, along is very challenging. One place where I've had some success in finding these types of individuals in organizations is looking for the folks who I would classify them as wanderers in a good way. So these are the folks who have worked in multiple functions, who have moved around the organization, who have taken on different roles and responsibilities, who have seen problems from different perspectives and different sides of the coin, if you will, who have been, roughly speaking, on the side of the organization that might, quote unquote, produce data, and then on the sides of the organization responsible for consuming that data and turning it into other aspects, either decisions or filings or what have you. Having experience with those multiple viewpoints gives people a perspective on the data that flows in an organization, which is very, very valuable in these types of transformational programs. Another aspect of looking, you know, for leadership on these types of things is it's very typical, I will say, to find people, like I said, who have had that experience from seeing problems from the different mindsets, and find that they have attempted to try to fix things or solve certain problems in the past, try to get people working around them or with them, you know, to do things differently. They may have tried to, you know, implement, you know, particular systems in the past with this kind of mindset, and, you know, those not necessarily, you know, those may or not have gone well, let's just say. So burnout from past experiences and change weariness in general, you know, is also something to watch out for. In finding the leadership for these kinds of programs, you want that balance between the experience, you want practical understanding of what has worked and what has not worked in an organization, but obviously you don't want the skeptical, healthy questioning, basically, of the ways to do things to have gone into cynicism. So you really, being aware from an organizational standpoint of the people aspects of sort of setting up these programs is very, very critical. So that's one sort of aspect of tooling these teams to drive these kinds of programs. Another thing is actually the people. Some comments about the people aspect during these kinds of transformational programs. As you're developing your roadmap and executing and working changes into the organization, an important part of the planning around digital transformation programs in particular is that you really need to make sure that you're allowing time in your plans basically to iterate, and that's another one of those buzzwords that's been kicked around a lot over the last several years with the from a methodology standpoint in and around IT projects. So all of those things apply, right? But even more so in these types of transformation projects. The only way to really sort of allow for absorption and to be able to learn from the absorption process in these large change kinds of programs is to make these allowances to wall time. So it takes people time, to scientists, to anybody actually, but scientists in particular, it takes time to absorb potential changes in the way that things are done, in the way that data flows in the organization, the way that data is used. And no matter how much effort you put in to doing, the analysis, which we'll talk about in a little bit here, doing analysis and planning and all the careful type of work that you'll do before you make investments in things and make changes to the way the data flows in your organization, et cetera. No matter how much effort you put into any of that, all of that, it's never going to be 100% correct. It's never going to be probably 80% correct, honestly. The thing you have to build into these types of programs is an understanding that you should do a certain level of analysis. I'm not arguing that you shouldn't do that. Do the analysis, do the planning, define the iteration, put it in place at some level, let's just say. It doesn't mean you have to roll it out to the whole organization, but put things in place, give people time to absorb it and understand it, and listen to what's actually happening from that. And if you use that to check the direction of your roadmap, and if it's not aligned with what's happening or what you expected to happen, taking these steps along this path, make sure that you're able to actually take actions to make changes. Don't make a plan for 3 years worth of work, embark upon it, not giving yourself enough time to iterate, to check on the direction you're taking and make changes to things. The end goal, we can put some stakes in the ground around, but the way to actually get there, there's so many aspects of that are dependent on, all kinds of things about an organization and the culture of folks working together, that it's very, very difficult to get that type of detailed plan out. Much more so in these types of efforts than traditional IT projects. Frankly, a lot of this goes for very large scale systems rollouts as well. But with these types of transformational programs that are really focused on the way, not a systems approach to data, but how an organization generates and actually uses data, it's even more critical that you allow for this type of iteration and this type of thinking. So I've talked a bit about iteration and sort of what that means, and again, this would be the specifics of what I mean vary depending on the nature of the workflow and the process and the data we're trying to get our arms around. But in general, this is kind of an overarching cartoon of the type of iterative improvement I'm speaking of. So from your current state, your current data flow, identifying within those, where the pain is, what are the use cases that could be, that define how improvements could actually be made. And for these types of things, those typical use cases are things along the lines of interdepartmental coordinations or intersystem, types of things where there's, pain today. elaborating those use cases, mapping those to what your infrastructure, and what your systems space actually looks like now, potentially running a loop there a little bit around, okay, we need a little more information about how this data is actually produced and how and who's using it. And then running sort of the classic, putting it into place, testing it, repeat, rinse, lather, rinse, repeat, right? You will identify as part of this process, you should expect to identify certain parts of these use cases where there's a level of significance to them that rises to become, something more than just sort of tactical, operational, kinds of things in a lab. There's an aspect to the data or the way the data is used or consumed that is actually strategic in nature. And I'm not advocating changing the process for these types of things. I am advocating sort of highlighting those things that actually do come out during this process, during this type of exploratory analysis, so that those things are sort of called out and given the proper weight. One other note I'll make on iteration that kind of overlaps with this next section around process as well, is that it's very helpful from a tool kind of, a way to approach things, to run these kinds of large scale programs backwards. We tend in IT projects to focus on data creation. So we tend to define the implementation of a system or the implementation of a workflow in a system, from the perspective of I make a material, I test a material, et cetera, from the point of view of what I'm doing when I'm actually creating data. When you're thinking about and getting into digital transformation programs, one I think very useful, in my experience, piece of advice that I've given folks on how to construct this thinking is go backwards first. Go to the people who are using the data, who are actually faced with, putting the filing together or putting other internal technical documents, types justification, kinds of things around processes, et cetera, putting those things together. Look at what they're using and where they're getting that information from, and who they're relying on in their communication pathways, and work backwards towards the creation of the data. That's a different way of looking at sort of the iterative approach in a large scale program like this that, like I said, in my experience has some value to it. Okay, so we've kind of been walking into this aspect of the process. We talked a little bit about the people involved in these types of programs, the process for actually doing a digital transformation program. Classical process analysis is one of the very important tools here. I'll put a different adjective in front of this and I'll call it practical process analysis. And more specifically, what I mean by that is we're talking about process analysis for the sake of the business processes we're trying to optimize, okay? We're not talking about process analysis of the processes themselves. This is not classic sort of business process engineering in terms like things like detailed time and motion study, kinds of things. I'm not dissing that type of work, and there's a role and a place for that. But within the context of a digital transformation program, there's an aspect to this process analysis that's very important, like being able basically to say, that's enough, that's sufficient an understanding of how this part of the process is actually working from the point of view of the overarching data flow in the organization. And because in these kinds of programs, part of what you're doing is envisioning and mapping out some future state where the data flow in your organization is more seamless and more steady state, et cetera, et cetera. If doing the detailed work, those details, if you're successful in implementing these types of things, those details are going to change considerably. And we don't want to micro optimize before we macro optimize. That's a really important part about this. So when I talk about process analysis in the context of a digital transformation type of program, it's very much the classic sort of high-level process improvement opportunities that you'll find everywhere. I see these things in absolutely every organization, even ones that have had a long history of sort of what I would call heads-up systems implementations, meaning they haven't, they have actually paid attention to some of these things, like the end, consumers of the data driving the beginning, the creators of the data, et cetera. There's manual keying of data that exists everywhere, in all over the place. There are scientists in the laboratories who are repeatedly doing the same thing over and over and over again. These are classic opportunities at the high level process analysis, things to call out, to be incorporated into these types of digital transformation programs. Communication processes, particularly things like interdepartmental types of communications, inter-site communications, like how do people work together, how do they collaborate? And another interesting thing to look at from a process kind of point of view is what people do before and after they use systems. So again, the IT perspective is like, okay, we're implementing LIMS system. We put our heads down, we do requirements, we do all these things, we implement the LIMS system, we do all the classic sort of, testing and everything else, and then we operate it with a system owner and a business owner, et cetera, et cetera. The blinders of a LIMS system, are sort of implicit in all of that stuff. What do people do before they get to sit down in front of the LIMS? What are they doing after they're actually using the LIMS system? And this can be one of the more challenging things to break down in some organizations. It goes to the cultural parts of things I mentioned before, but getting in there and really looking at what the scientists are doing to get ready to use the LIMS system and what they're doing after they've used the LIMS system is a really useful part of the type of process analysis that I'm speaking to here in these digital transformation programs. Okay, a little bit more on iteration, although I've spoken about quite a bit about it, but just some additional thoughts on sort of the nature of iteration in these kinds of programs. No matter how much time you spend with PowerPoint and Visio and whiteboards and everything else, how much time you spend either, in virtual meetings or in physical meetings, and we used to do that, no matter how much effort you put into these things, we are incredibly immature at sort of the overall process for gathering true requirements at the level of a digital transformation, right? I mean, it's very difficult to have sort of written documents convey all of the subtleties and all of the things that are actually impactful sort of on some of those aspects of organizational efficiency and data use in particular. So again, not arguing against putting together PowerPoint decks and Visio and whiteboards, use them all the time in these, but you also have to really sort of be prepared to get out there and do things in order to test all the stuff that you're putting together in your PowerPoint decks and your Visio and your whiteboards. Another sort of key aspect that I found, or approach that I found useful in these programs around iteration is working breadth first, so going end to end. So this is not sort of a classic system deployment, functional functional spec, RFP, technical design specs, et cetera, et cetera. This is about outcomes of the organization. So, working it, like possibly, as I said, working it from the point of view of the filing document that's put together back through all the sources, and making sure that you're actually working that all the way end to end, going truly end to end across the organization, the systems, following the data, right? Driving to the outcomes of things before you go deep, right? Before you, take the, follow your urge to basically dive into, okay, so how does that instrument, how does that instrument integrate with the LIMS system, and what data is actually coming in that stream, and how does that data archive, and all those kinds of things, right? Before you dive deep, make sure that you get the process end to end, because it's rare that, at the scope of these kinds of digital transformation programs, that it's never about a single system. It's about business outcomes. It's about what is the scientific purpose and intent of this process. And so you got to put the systems away and really look at the process end to end. And in fact, I've tried, and this is very, very challenging, very difficult, but I'll put it out there as a goal, as a useful tool. Try to fundamentally forbid the discussion of systems while you're doing this kind of work. It's really, really hard to do this because that's what you feel and touch. And I use the LIMS system to do this, and then I use the CDS to do that, and then I got to go back to the LIMS to do this, et cetera, right? it's okay to use analogies to the current systems. Be careful of letting that analogy go too far and sort of direct ultimately the way the process should work in a future state. It's very difficult. It's very difficult to achieve this, but I like to try to basically say in all these discussions, let's not get into your ELN versus your LIMS, and I don't like, especially things like I don't like vendor X and I love vendor Y, I used them before. Those are distractions to getting to this overall point of view of what the business, the scientific architecture actually is, the end-to-end business flow in the labs, in and around the labs, and the data flow that's actually got to support that. When that's done for an organization, as the process actually becomes the data itself, you should be able to be driving out these key components of whatever your future state is, whatever systems are involved, and things are going to change with your systems and what your systems landscape is over time. You're going to realize from a data perspective that everybody depends on this package of data that's actually created over here and updated over here and passed to these people, and it goes through all of these other stages and gets annotated in the following ways. All of these things happen to it in its life cycle, and it's not about the data. It's not about the system. It's about the data. And that viewpoint, getting to that level of understanding and building a program basically around how do we construct data flows that actually are system independent to me, it's a very critical part of having these kinds of programs have long-lasting, sustainable, impact. At the end of the day, you should be building out from this a practical data architecture. It goes along with an understanding of the domain boundaries. Who's really responsible for creating the lots and the samples and, et cetera, in the organization. Those boundaries are really critical in sort of breaking down these data problems. Who really owns, the responsibility for this data? Who's responsible for vetting it and curating it? How is it actually used? How is it interlinked? But breaking down sort of the elephant in this way for that kind of a holistic infrastructure is a really critical part of supporting the transformation of the way organizations actually work. Data will become systems. So, by saying, don't talk about systems, it's obviously sort of ignoring the real world. At the end of the day, we're going to have to implement these things, and eventually it will actually become systems. What you've done with your data architecture, ideally, actually, is to build a contract for all of the systems in the organization. If you are going to interact with a sample in this organization, then this is how we define that sample. And that shouldn't be a definition that's independent of whatever your LIMS system is, or whatever your ELN is, or whatever your other systems actually are. It should be a universal understanding in the organization of what the digital notion of a sample actually is. And it should be then a contract that the systems that are going to enter into some relationship with data associated with the sample, whether it be producing it or just using it, that's the contract that they actually need to abide by. So what you're building out here is a data architecture with a high-level picture of your systems, and creating, one of the other tools here is creating what I call a reference architecture for the systems. I'll explain that more on the next slide. But what you're actually attempting to do here is lower some aspects of complexity in your environments. You don't want to have a large number of different interpretations of what a sample is. That's one of the things that leads to high complexity and challenges, especially in large systems, or when you're dealing with labs that are distributed around the globe and a couple of thousand people, a couple thousand scientists, et cetera. You're really trying to build simple models here of the data, again, that all the systems actually have to participate in. One of the other comments that I'll make on the systems perspective is kind of aligned with some of the things I said before, that, interestingly enough, in a lot of organizations, not all organizations, but a lot of organizations, when you get to this point and you're really looking at, okay, now we've got a process understanding, of how our science needs to go and how the data that supports that actually needs to go. Now we're looking at how to put it into systems. Interestingly enough, we all have a whole plethora of systems, sometimes more than we need. We may have gaps, but truthfully, these days, there's fewer gaps than there are redundancies in most places. I'm excluding obviously sort of startups, and that's a different sort of space, if you will. But in my experience, it's very likely that the current systems that you have are actually probably going to be a sufficient starting point for use in any kind of digital transformation program. It's relatively not unheard of, but it's relatively rare that a whole new system actually needs to be brought in. There are pretty much all of the current systems that we have, ELNs, LIMS, CDSs, et cetera, et cetera, et cetera, have a lot of really good baseline building block kinds of capabilities. And these programs, these digital transformation efforts, tend to be more about how we apply those capabilities than the actual sort of functional specifications or design specifications of these actual systems. So it is the case a lot of times that we can, in doing this kind of work, that we can go back, look at what we're really trying to put together here, and find ways of actually going back to iteration, iterating, prototyping, showing how that would be done on top of the current or in and around the current system architecture. So a little bit more on that comment about reference architecture. So whenever you get into systems, one of the challenges is in that cultural aspect of, I like LIMS vendor X and you like LIMS vendor Y, and my LIMS can do what your ELN can do and vice versa, and all those types of things. And to run a digital transformation type of program, this is another tool I found very helpful in sort of keeping the discussion around systems focused on the goal of digital transformation. So building a high-level picture of systems, not vendors, systems, and their role in these organizations goes back to the comments earlier around domains and such. So obviously this picture of reference architecture is very dependent on whether or not you're talking about digital transformation of an entire large organization or digital transformation of a testing lab. But as an example of a cartoon example here is this kind of picture, right? So we have a message bus that allows our systems to speak to each other. We have a LIMS, we have an ELN, we have a CDS, an archival warehouse, and some reference data. So, this seems really simple, and it is really simple. But it's very useful when we get into the projection of what our future state workflows and our future state data flows actually are to understand these types of roles. There's a whole other talk I have spent in some places several hours about why do you need both an ELN and a LIMS, and there's a lot of details sort of behind this, but for the moment, this idea of creating a reference architecture is creating these types of slots or understandings for what are the pieces that we need in our environment. Why is this important? Because at the end of the day, when you project the data flow back onto this, it gives you a much stronger understanding that you can use in basically driving those requirements. Like LIMS deals with the following entities. These are the requirements. LIMS and ELN will have a common understanding at a level of the organization of what a sample is, et cetera. And what we're trying to avoid in the system space is that, right? What we're trying to avoid in the system space is something that if we come in and touch it to make a change in a scientific process or a data flow, the whole thing comes tumbling down on us. Now, one long-term useful tool essentially or outcome of these types of reference architecture pictures is helping to avoid the Jenga tower, right? Now the current state, there obviously is back again, you might have a current state that is the Jenga tower, and it's a different set of problems to discuss. Okay, how do we implement digital, high-level organizational data flow when we have a on-the-ground systems architecture that looks like that, right? Anytime we touch this, we try to upgrade, any one of these pieces or make a change to the relationship between any of these pieces, and we're running a high risk of the whole thing come crashing down. But the goal of the program is to be able to get yourself on a footing that your systems architecture doesn't look like the Jenga tower. So you want it simple, you want to manage the complexity. There's a lot of complexity in this, in the details and down in the practical, how do we make this work? I'm not saying that complexity is avoidable, but if you don't have a reference architecture that's relatively simple, like the one in the cartoon here is, then your probability of having a real-world practical implementation or deployment architecture that isn't the Jenga tower is pretty low. So you need to have a simple high-level understanding across the board, whole organization kind of across the board of what that reference architecture looks like to avoid one of the tools in avoiding the Jenga tower. Okay, so I'm going to wrap up with a couple thoughts here, and then we'll have some time for some questions. One other theme, let's just call it, that I've seen over and over again in these kinds of programs at all sizes, very large ones or relatively smaller digital transformation programs, is the team letting good enough become the enemy of perfect. I mentioned this before when I was talking about business process analysis and doing it in a practical way and learning when to say enough, right? In large transformational kinds of programs like this, where you're really trying to replumb the way the data moves in the organization, it's very easy to drop into the details. I was educated as a scientist. I've been an IT person, research IT person my whole career. I got the mindset, I love to drop into the details. That's a very common mindset in both IT worlds and from a scientist point of view. You have to fight against that, but basically the whole time. You have to make sure that you're trying to stay above the level of trying to get through all of the different ways something could go wrong. And really make sure that you're thinking and looking end to end. So I see this happen a lot, right? That there needs to be a voice, in these kinds of programs that says things like, okay, we need to move on from this so we can look at the next step or the previous step. We will come back, to elaborate these kinds of details. Another sort of summary parting thought, and again, I mentioned this earlier, digital transformation is not a buy and deploy it kind of project. There's nobody who sells you what you need to operate as a data-driven organization. There's no single vendor you can go to that's just going to magically sell you something and you can put it in, roll it out, and declare victory. This is in the R&D space. This is a project that's about the scientific process, and everybody has different strategies and goals and cultural aspects that feed the way they view the scientific process actually running. Again, the systems piece of this is actually the simplest of all of it. It can be messy, but relatively speaking, it's the simplest piece of it. Driving the science and driving everything back to what are the scientific outcomes that this whole thing is trying to support. What's the data that's critical? No matter what systems we have or don't have, understanding the scientific workflow and the data workflow is absolutely critical to being successful with these. And then the last parting thought, again, I mentioned this very early on, I just wanted to bring it back here at the end, which was a large part of this, and there's some interesting articles that have come out and things like Harvard Business Review, some letters and comments and things along those lines about digital transformation programs in other industries, which really are talent projects, talent identification and talent development kinds of projects. Finding the people in the organization who have the wiring in their brain or whatever, the predisposition to thinking this kind of way, thinking bigger picture about data flow and those types of things. Identifying those folks, developing them, getting them to develop more people, getting that cycle going is a really important part of making the impact of any program like this sustainable and sustainable and growing even in the long term. And so like finding those people, putting them in the right place, giving them the opportunity. I'm a very big fan of rotational types of approaches to folks in scientific organizations as parts of this. Identifying a person, bringing them into a core part of an iteration of a part of this data architecture, and then letting them go back to their day job, so to speak, their scientific job, and encourage others around them, finding somebody else, bringing them in. Those things tend to work really well as part of person development in these. So a few parting thoughts on all this. Okay, so that's the prepared material that I have for today, and take a break. I'm going to grab a sip of water, and we can take some questions.
Hey, Dave, thank you very much. Let me go ahead and do a couple things here. First and foremost, I'm going to go ahead and stop